in a mode, range and mid-range is also in that umbrella topic. Not really so much the range, but in order to understand mid-range, it helps to talk about range, right? So the notation for the mean is the symbol x bar. All right, so x with a bar over it, very creatively called x bar. All right, so that's equal to, the notation can be a little funky, the sum, so that's the funky looking e, of x sub I over n. That's shorthand notation, but it gets the idea across. All right, so that symbol, that funky looking e, that stands for sum. And that x sub I represents an individual, I for individual. Not really, but it seemed to make sense. Individual values in the data set. So individual data values. All right. And the n is the total number of values that make up the set of data. So all right, so total number of values, not the total of the values. All right, so it's actually the top that is the total of the values. If you add them all up, you get the top of the fraction. You count them all up, you get the bottom of the fraction. All right. So x bar here is going to be all of these data points added together. So 15.1 plus 17.5 and so on. Divided by, there's 6 values in the data set, so divided by 6. All right. If it's a small data set, you may just want to do it by hand rather than using the calculator to, and you know, built-in functions in the calculator are great. You know, it'll find the mean for you and everything. But this might be one of those instances where it would take longer to type the data in than it would be to just find the average, right? So if I'm going to the calculator just for the sum, hit the home button, go right to calculation. All right. And you know, you can even use calculators on a computer, whatever. It's just simple arithmetic. All right. So I would take the 15.1, add to it the 17.5, add to it, and so on. You know, 18.3, 14.1, 3.2, and 6. You know, you could strategically add values that you know the sum for. You know, like maybe you type in 9.2 instead of 3.2 and 6. You know, it's up to you. But we have 74.2 for the top number. Let me do that in a more intelligent way. 74.2 divided by 6. All right, so divide by 6. By hitting the division key, I know we don't all have the NumWorks calculators out right now. I have them here. You can use them whenever you need them. Just the general rule of thumb there is like just always put them back when you're done. But if you hit an operation like division, it's going to take whatever you had as a previous answer and divide the results. Divide that to give the result is what I should say. All right, so enter. We get 12.367. If we're rounding, what we do is we round to 3 significant digits. All right, so round to 3 significant digits. All right, that's not sig figs, if you're familiar with that from a science class. This is significant digits. What it represents is the first 3 values after the zeros end in a decimal. All right. So what we do is we ignore any string of zeros after the decimal, which is irrelevant in this case. Right? I don't have any zeros after the decimal. Oh, schneid. Thank you. I was writing good notes here, too. Now I'll pause to let you actually write them down also. Yeah, but ignore any string of digits, string of zeros after the decimal.
Quick question. So would you prefer when we're writing like a decimal that goes on, forever, to just round up to the nearest whatever?
Yeah.
Or put the line number?
You could go either way, but the preferred approach is to round it. Yeah, it's one of those things, like in an algebra class, they would want you to do the line over it, but here we're using it for computational purposes, so odds are I would have, under normal circumstances, I'd have to do something with this number after I made this computation, and so we would want to follow the same rounding, they call it a rounding convention, so whatever the rounding technique is that we're using, we use for everything, all right? So just very quickly, I'll show you an example, because it didn't really come up in this handout, but I'll show you a case where the rounding isn't necessarily as cut and dried as just the first 3 decimal places. All right, so for example, let's say you have a decimal 1.0001259901. All right, off the top of my head. So when you're rounding this to 3 significant digits, what we're going to do is we're going to ignore the first 3 zeros here. That's a string of zeros. You could also call it a run of zeros or a streak of zeros. But bottom line is, if the first entry that you see after the decimal is 0, then you move on to the second entry. If that's still 0, then you move on to the next one and the next one until you get to a non-zero value. All right, so this is where I would start my rounding and round to 3 places. So the 1, 2, and the 5 are going to make up my answer, but because this 9 is bigger than a 5, it's the if it's 5 or above, give it a shove. If it's below, let it go, something like that. So 1.000126 is what this would round to. All right. And really, the whole point behind this is, if I were to round to 3 decimal places, I would lose a lot of valuable information. Right? I would get 1.000. Anybody looking at that would be like, well, isn't that just a 1? Right? But here we're looking at, it's infinitesimal. It's like teensy tiny value bigger than 1, but that could be meaningful because we don't know what we're comparing it to. Right? So once we have that context, it starts to make more sense why we do things the way we do. Right? But it's a strategic approach, but as long as we follow that consistently, then we're in good shape. The median of a data set, you just want the middle number when the data is put in order. Right? So there's a couple ways you can handle that, but most people, when they're first starting out, just rewrite the numbers in order. All right. So in this case, it would be 1, 2, 3. We got 4, 6, 8, 9. Then 14, 24. Those would be the values in increasing order. It's a small sample. All right. If there were 100 values, I would want technology involved. All right. I wouldn't want to actually write out 100 values in order. All right. But it's a small sample, so it's not a big deal. So what I would do here is I just work my way to the middle. So, And whatever that middle number is, it could be one number, it could be two numbers. If it's one number, that's your median. If there's two numbers, you find the average of those two numbers, and that would be your median. All right. No, these are notes. This is gonna help you complete the activity that we started out from. So, part B, I don't want to write the numbers in order. So what I can do is just kind of learn from what I did in part A, where, yeah, I wrote the numbers in order, but then I crossed off the smallest number with the biggest number. Then the next smallest number with the next biggest number. Then the next smallest number with the next biggest number. Why can't I do that with the data out of order? I can. Say it again?
It's an even amount of data.
We have an even amount of data. So then we're looking for the two middle values. So that's the one thing you have to keep in mind that makes it different for part A, is that we're on the lookout for two middle values. But if I cancel the smallest number with the biggest number, then the next smallest number with the next biggest number, then the next smallest number, well, the next smallest number is 2. There's 2 of them. I'm going to cross off one of them with the next biggest number, which is 4. What I'd be left with are 2 remaining values here. So I would take 2 and 3 and average them together. And that's going to give you 5 over 2. You could write 2.5. Or 2.5. In this class, decimals are our friend. So 2.5 is the way I would express my final answer. But anything that you write that's equivalent, simplified and equivalent, is going to be perfectly fine. All right. So that's the median. The mean and the median could also be done on the calculator. But again, like I said before, sometimes it takes longer to just type a set of data in than it does to actually do the number crunching. Like in this case, with a small sample, very easy to come up with the median quickly, all right? As opposed to taking the time to put it in your calculator to find the answer that you probably knew already, all right? The mode is not something that the calculator is going to easily help you with. So for that, we just do it by hand. You're looking for the most frequent value. So in the first case, in part A, the mode would be what? What do we say? Either the fan squeaked or somebody said the right answer. The mode is what? What number occurs more frequently than everything else? 7. Lucky 7. What about in the second set of data?
Technically 1 because there's an 11 in it.
Technically 1 because, well, as we all know, 1 plus 1 is 11.
Obviously.
Yeah, there's no value that occurs more frequently than any other value, so we'd say none. All right. What about C?
There are 2.
There are 2. What are they?
1 and 3.
1 and 3. Exactamundo. Now, for part D,
3.
the number 3, exactly. Very good. Yeah, because, like, that's the thing. You look at repeated values, and you fall in love with this idea of, like, oh, if they're repeating, that's part of the mode. It happens so frequently that students will, without even really thinking, they're like, okay, everything is, like, 1, 2, and 3, they're all repeated, so those are my modes. But it's the most frequent one, the one that occurs more frequently than every other number. And so in this case, that's the number 3. All right. I'm just going to snag a quick example here, like that first data set in the median, just to show you really quickly or remind you how you find the measures of center on the NumWorks calculator. All right. If anybody is like really dead set against the NumWorks and they want to use a TI calculator, that's fine. It's not going to be a problem. I'll just need to show you how to do some of the stuff on the TI that we do on NumWorks. But I'm going to go to my house icon here. I'm going to go home, go down to statistics. If you don't have any data values in there, that's ideal. But if you do, then you go right up to the column heading, hit enter, and then you'll see an option to clear the table. and then it'll clear it. But there was nothing to clear, so, you know, it was kind of a waste. But you also see these other functions like fill with a formula. You could actually define formulas that will fill in the table for you if you know what the relationship is from value to value. Let's say, for example, you needed to put the numbers from 1 to 100 in. You could actually create a formula to do that as opposed to typing in 1, 2, 3, and so on. Right? But that's a different story for a different day. So I'm going to type in these values. I'm just going to go with this data set here. All right, so 6, 8, 4, 3, 1, 2, 9, 14, and 24. All right. You see that the frequency column contains a 1 for each item that I just entered. All right. The reason for that is I only typed in the 4 once, the 3 once, the 6 once. You know, so if I wanted them to be represented more frequently, like in mode part D, then I could say 1 with a frequency of 2, 2 with a frequency of 2, and go down the list that way. Right? It's kind of a more streamlined approach. But all I really want is the mean and the median here. So I go to stats, enter. It tells you the median is 6, which we already knew. If I wanted the mean, I just scroll down and it'll tell me what the mean is. Now this question didn't ask us for that, but it's nice to know that that information is there. The good thing about the stats menu is it's one-stop shopping for all the computations that we would need to do. All right. It's very rare in a statistics class that you would be asked to do any of this stuff by hand, like for real purposes. Like if you're using it to draw a conclusion from a data set, nobody's going to say, aha, great graph, but you didn't do it by hand, so it doesn't count. It's never going to be like that. The only time in a stat class that you're ever asked to do something by hand is for the purpose of making you do something by hand. Yeah. Sometimes it's like, well, you'd like to understand why a formula works the way it does, but most of the time it's, I'll call it punitive. It's like, we need to kill a class period, so make them do it by hand. It'll take 40 minutes. You know, that's usually the case in a stat class. So that being said, I won't be doing that to you. But I will show you how to do stuff by hand just so you have the information, but I'm never going to ask you to do it yourself by hand. All right. So calculator is going to be the way to go. You can also decide on your own if you want to do something by hand, but I don't encourage that. All right. So with that in mind, I'm going to show you how to make a pie chart by hand and a bar graph. Okay. Calculators, computers do this stuff very well. We will be mixing in spreadsheet math, so Excel, Google Sheets, things like that. So you'll have the ability to construct by hand. So if you think back to the activity, there's one question that asks you to make a pie graph. So a bar graph and a pie chart. Right? I say construct those things. There's no place in those questions where it says to do it by hand. All right. So today I'm going to show you how to do it by hand, but I'm also going to show you how to probably tomorrow show you how to use Excel or Google Sheets to do that for you. But a bar chart, very easy. The horizontal axis is whatever the categories are. So that's going to be JJHS. Again, thank you. Yeah, that's probably going to be an ongoing thing, unfortunately. So JJHS on the horizontal axis, you could put JJHS students if you want, but whatever the label is for your categories, that's what you put on the horizontal axis. All right. Vertical axis will be the number of students. All right. Now we need to get as high as 336 here. So it sounds like the kind of thing where we're going to have to do a little estimation. You know, because 324, if I'm going by 25s, for example, that's going to be just a smidge below 325. But I could even go by 50s. I can go by hundreds. you kind of want to figure what the happy medium is in terms of having as much accuracy as you can have while putting in as little effort as you can. All right, so I'm thinking 50s. So each tick mark could be 50. I could have gone by 25s, I think. I'm not 100%. I might have been one off, but 50s gets the job done. All right, so we'll go high enough to capture all the data, but without going too crazy. All right.
Could you technically start it at like 200 if you use squiggly lines underneath, basically saying that you're starting a little higher, but then continue doing 225, 200, 225.
For other graphs, yes.
Just not for this.
Not for this one because it's categorical.
Okay.
Right. So you can put, and this is how graphs can be deceptive. I can take these categories and put them in whatever order I want. They presented it as seniors, juniors, sophomores, and freshmen. So my tendency is to say, well, let's go in that order. But you can go in whatever order you want. All right. There's no rule that says that you have to follow based off the categories, follow the order that the information is presented in, as long as you make sure that the number of students corresponds to the correct category, you're fine. Oh yeah. So for seniors, now, and you can space it any way you want, I'm going to make that my first category. Give it a little space, then go with the juniors, then the sophomores, then the freshmen. All right, abbreviating the living daylights out of it. All right. If you were to do this using technology, it would be a well-labeled graph. It would look beautiful. But if you're doing it by hand, you just get it done as quickly as you can while satisfying all the requirements. So the first bar is going to go a little short of halfway between 300 and 350. Doesn't have to be perfect, it's just got to be in the neighborhood. .336, I mean, if I'm estimating 324, then I'm really estimating 336. I don't know where precisely that should be. I do know that it should be a little bit higher than my first bar. All right. So probably something like here. Then 264, somewhere north of 250. Oh, you know what? I put my bar. Sorry about that. That's my bad. Bar charts have a space, so you got to leave a little gap. All right, so 264, somewhere north of 250. All right, do the best you can. I know for you all, you're freehanding it. I have the autocorrect tool, and even still, it doesn't come out so great when I do it. All right, so this one is going to be a little bit north of the previous bar. And that would be my bar chart. Yeah, some people like to color it in and stuff like that. Again, when you're doing it by hand, the whole purpose is to get it done efficiently. So as quickly as you can while satisfying all the requirements of the problem. All right. If you want color and well-labeled diagrams, then you go to technology anyway. All right. So then you get into Excel and go that route. All right. The last thing that we're going to do, I keep forgetting what period it is. The last thing that we're going to do is the pie chart, and then if you need to collect data, you can do that, or you actually start tackling some of the problems. But yeah, this one, it involves a little bit more computation, right? So what we want is, so we have the number of students, we want the proportion of the circle. So that's a decimal value that represents how much of the circle each category accounts for. All right, so what I need here is a total. I'm just going to do it quickly on the handheld so I don't forget to change screens. All right, so 276. Okay, so there's 1,200 values. All right, so you add up this column here and you get 1,200. All right, the proportion of the circle is the decimal value accounting for each category. So what I would do for that first one is I'd take 324 and divide it by 1,200. Then 336 divided by 1,200, 264 divided by 1,200, and 276 divided by 1,200. All right, so we're going to get approximate values, and they really can be approximate. We don't have to adhere to any strict rounding rules because we're going to estimate the angle, the degree measure anyway. So when I take 324 and divide it by 1,200, well, surprisingly, that actually gave a pretty clean answer, so 0.27. All right, but if it's at 0.2695, blah, 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 I would probably ballpark it at 0.27 anyway. All right, 336 divided by 1,200. Actually, now that I think about it, most of these are clean, if not all of them. 0.22. And then 276 divided by 1,200, 0.23. This column should add up to 100. If it doesn't, then you made a mistake. All right? Or at least it should add up to something that rounds to 100, not 100, 100% or the number 1. All right, so what we're going to do now is take each of these values and multiply by 360 degrees. All right, so I'm going to take my 0.27 multiplied by 360. I get about 97.2 degrees. 0.28 times 360, 100.8. 0.22 times 360, 79.2. And then 0.23 times 360, 82.8. Okay, so that's just basic computation. But we need those values in order to make the pie chart, right? I don't want to speak for you, but after doing this, there's a good chance that you're going to get annoyed when I show you how easy it is to do in Excel, right? Because it really is type in the original data table, then select pie chart, and it does everything beautifully for you, right? So maybe you're annoyed right now. We'll see. But anyway, what I'd have to do if I want to do this by hand is I have to get a protractor and draw the angles. All right. So I'll do it real quick for you, and then I should have some protractors around here somewhere, so then I'll pass those out. But what I would do here is get my protractor out, if I could find it. There we go. So I got my protractor. I'm going to measure off about 97 degrees. If you could, from a protractor, estimate where 97-ish degrees is, then you're better at this than I am. So it's really just a ballpark estimate, right? So I have my protractor. I'm calling this 0 degrees. 97-ish would be about right here. All right. So what I would do is connect the center to that first marking best I can. close enough. That's going to be my set of seniors. All right, we already have the numbers in the table, so I don't need to write anything more than that. The next is 100.8 degrees. Now that's 100.8 degrees beyond what we just created. All right, so I want to be careful about this. I don't want to, for example, in this case here, just mark off 100.8 degrees. That's not going to be correct. But what I can do is go the other way with it. So I can flip it, my protractor, and measure off 100.8 degrees the other way. All right, so 100, about right here, so 100.8, right in that same neighborhood. All right. So then this would be my set of juniors. All right. Another way that I could have handled that would have been to add these two entries together and measure that off from 0. All right. So I could have gone either way with that. In fact, what I'll do now, because I only need to label off one more, because then whatever's left over would be the last category, I'm going to take these two numbers and add them together. All right. So that's going to give me an even 180. So if I take the juniors and add to that group the sophomores, that should give me 180 degrees, which is half of the circle. So I don't need a protractor for that. I just extend the 0 line. Here's 0 degrees. I extend it in the opposite direction. So now I have my set of sophomores, which means that the remaining group have to be the freshmen. All right. It's really just a matter of measuring off angles, but you need to have the angles to measure off. All right.